Hello, my name is Chuck Sinelli, and this recording is for Environmental Science 1. This video, Introduction to the Earth System and Cycling of Materials. Notes for this presentation can be found as an attachment underneath this video. The video is very user-friendly. You would be able to pause and replay any content as needed, and able to be able to take notes to stop and go back and catch information that you missed. Okay, so let's talk about the Earth as a system. When we think of breaking down planet Earth into its major parts, scientists call those parts spheres. And so the Earth as a system really is a way of thinking about the Earth as its individual parts. And we'll talk more about how that works and how they interact with each other. But at this point, I'd like you to think about what would the four major spheres of our planet be. And one that the hint go ahead and gives you here is the geosphere. And the geosphere is the part of our planet that is responsible for the rock, the solid material that makes up our planet. It includes the crust, the mantle underneath, which is liquid magma, and our core of the planet. So what I'd like you to do now is go ahead and pause this video and brainstorm and think about what the other three parts of our planet might be. Take some time to do this on your notes and then restart the video. Okay, so hopefully you've had some time to go ahead and think a little bit about what those might be. If you have something different than what I'm going to place in these boxes, just feel free to keep what you have and add what I put in. In addition to the physical rock of the Earth, another major thing that you might have thought of is all of the water on our planet. When we look at the Earth, we are really thought of as we call ourselves the blue planet because we are covered with liquid water. That sphere that includes all of the water on the planet, in the crust, on top of the crust, in the atmosphere, all of that water is known as the hydrosphere. And you're hopefully seeing a theme by now that all of these different words have sphere as their root. So the hydrosphere includes all of the water on the planet that is liquid, frozen, gaseous, solid, or solid, frozen, all forms of water on the planet. Another part that hopefully you came up with, and the sphere gives it away, of course, is the layer of gases that we interact with on a regular basis, known as the atmosphere. And of course, like I said, it's the gases, the layer of gases that are above our planet that reach out up for several miles and have a range of different materials in them, gases, compounds, elements floating around in the atmosphere. And the last thing, and sometimes the thing that's the least likely for students to come up with, is really another huge major component of the planet. If you looked at surface images of the planet, of course, if you're over the ocean, you would think water right away. But when you look at a surface image of a continent, most of that continent will typically be green, and that is because of all the life that exists on our planet. So the fourth component of the Earth system is the life, and you guys may know that in science, the root that we use for life is bio, and so the biosphere includes all of the living components of the Earth system. So all plants, animals, bacteria, fungi, everything that's living. And so when you think about the Earth as a system, all of the planet and everything on the planet can be fit into one of those four major spheres. Now let's take a look at those spheres that make up the Earth system. So we have the geosphere, hydrosphere, atmosphere, and biosphere. And when you think about that, all of those things combine to make up our planet. Let's take a look at where on our planet we would find those things. I have a little picture to blow up here. In this picture, you can see that we have all four different phases of all four different spheres of the planet represented in these different diagrams. So you can see here the biosphere. We'll start with that. Is a layer of life, a layer where life exists that starts all the way down into the deepest parts of the crust, where life is able to survive, including at the bottom of the oceans and trenches, and even in rock and caves and other formations underground. In addition, and that we find that going all the way up to an area in the atmosphere near the peaks of mountains and up into the sky, where life is able to live up to a certain point. So anywhere in that zone is the biosphere where life can exist. Then here in that same picture we have the hydrosphere, which again, water is found in some of the deepest places in the crust that we go to. We still find water in the form of underground water, groundwater, and then obviously in deep trenches and that throughout the ocean. And that layer goes all the way up into the atmosphere to a certain point where water, gaseous water, no longer exists up in the higher reaches of the atmosphere. So all the water on the surface of the planet would be located within that zone for the hydrosphere. For the geosphere, you have all of the rock, all of the material, the compounds and minerals that make up the crust, mantle, and core of our planet. All of that would be considered the geosphere. And then finally you have the atmosphere, a layer of gases that's held close to the Earth's surface due to gravity pulling that down, that contains a host of different chemicals, molecules, all of them in a gaseous form for the most part. It's about 1,000 kilometers thick. So now you can kind of see where these things are on the planet. Let's take a closer look at what these four different things are. We have the geosphere. Again, like I said, that is the rock of the Earth. That's the solid part. Includes some things that you wouldn't think of. We talked about the crust, mantle, and core, but it also includes things like soil, which is a lot of soil is just broken down rock particles. You have sand, gravel, dust in the air. That all of those things are part of that mass of rock, of material on the surface of the planet, which is the geosphere. Lots of different processes and cycles happening inside the geosphere. The rock cycle, generating new rock, destroying old rock, plate tectonics, all of those mountain building, volcanoes, all of those things would fall, all those processes would fall into the geosphere. The hydrosphere, all the water on the planet, and like I said, we can find water all over, under, over the surface, in lakes, oceans, streams, in the atmosphere, and water vapor, frozen in glaciers and ice caps, and down deep underground in groundwater reservoirs. Water is essential to Earth, and a large part of it. Next up, we have the atmosphere. Again, it's that layer of gases surrounds our planet, held there by gravity. We kind of think of it as the air around us. We don't think a lot about the atmosphere as being a reservoir of molecules, but it stores a large number of gases and materials in the atmosphere that have an impact on us or that we need, obviously, like oxygen, for example. And of course, we know about carbon dioxide that plants use. And the last, and to us the most critical, where we fit into this puzzle, is the biosphere. And the biosphere is basically the life on planet Earth. It's a global sum of, you can think of it as a global sum of all the ecosystems. So all the living parts of the ecosystem fit inside the biosphere, or it's also known as the zone of life. So everything, plants, animals, bacteria, fungi, single-celled organisms, all the way up to some of the largest creatures on Earth, like the whale, the blue whale, the right whale, all have to work together within that zone of life to get the resources that they need. So how do things interact within this Earth system? Different spheres of the Earth system do not act independently of one another. That's a big thing to know. They're not, and they're also not just dependent, but they're interdependent. They're intertwined with each other in a complex system in which they rely on the process and materials of the other. So the hydrosphere cannot exist as it does without the other three spheres. So it's not able to act independently. It has to be a part of the Earth as a system. It's intertwined. And so I want to talk a little bit about that word, interdependent. Here's a definition for you. It's a relationship in which each member is mutually dependent on the other. So it's essential that all of the components work together, and our Earth system is a great example of interdependence. Some examples of how interactions between the different systems play out in this interdependent model. The organisms in the biosphere, for example, us included, rely on the continued supply of fresh water that the hydrosphere's water cycle provides. So water moves throughout the planet and within the hydrosphere, and all of the creatures in the biosphere rely on that water and rely on it to be safe enough and clean enough to drink and to use in their cycle, their life cycles. Another great example, that same water that we just talked about in the hydrosphere relies on the filtering action of the geosphere's soil, sand, and gravels to clean and purify water. So the geosphere, we don't think about that as helping us in any way, but it actually does. Organisms rely then on the geosphere to clean the water of the hydrosphere so that we're able to use that and be safe. So those are just a few examples of interactions. And later out throughout the course, you'll be coming up with more examples of your own as we explore this interaction between the different spheres of the Earth system. Now we want to start looking at how materials found within the Earth system and these different spheres cycle and move throughout the planet. Materials are cycled throughout the Earth system. Naturally, the Earth is a big recycling machine. We can think of it as a place where really no new material comes in for the most part, and no materials really leave our planet. So everything here is recycled. It's broken down, the Earth breaks down materials into their simplest elements and builds an array of more complex molecules. Materials are often moved with consequence to the spheres, so there's an impact there that they interact with. So when one sphere, when something happens, a process in one sphere will impact another sphere. These consequences have both positive and negative impacts on our environment. So a couple of examples of that might be, for example, water in the hydrosphere falling to this, as part of that cycle that we'll learn about when it falls to the surface of the Earth. Well, when water hits rock, let's say up in the mountains, for example, it slowly erodes away, and you guys have hopefully heard of that word, erosion, the rock at the top. So over time, the hydrosphere actually eats away at a key feature of the geosphere, the mountains. And that process, without the process going on in the geosphere, that process over time would eventually erode away mountains so that there would be no more mountains on the planet. Of course, we know that there are processes that generate mountains and push mountains up and create and build mountains. So those processes are in exact contrast to those. Of course, the animals and creatures that in the biosphere that depend on that type of environment, the mountain environment, that could be a negative. They could have a negative impact on that as the mountain region changes over time. They would be forced to adapt as that changes. Of course, that would take a long period. That would be over a long period of time. But there are also positive interactions as well with that same runoff carrying rock that was eroded from there. You end up with beds of material deposited down lower in the valleys. And so that rock and that material eventually turns into soil that is always almost some of the best soil for plants to grow in. And so along our riverbeds is always a great place where then plants are able to grow, because not only do they find great nutrients in that broken down rock that's now soil, they also are close to a water source. So those are just a few examples of how those interactions can be positive and negative. So we're going to talk a little about cycles, because materials are cycled throughout the planet. Cycles are kind of a pathway, in this case, by which chemical elements or molecules are moved through the different spheres. So they're moved through abiotic and abiotic compartments of the Earth through those different spheres. It cycles a series of changes which come back to the starting point and which can be repeated. So when we think about a cycle, oftentimes we simplify that. It makes a circle. But really, in a complex system like the Earth, usually there's cycles within cycles, and there's complexity there that sometimes we take for granted. But for the most part, materials move around throughout these spheres, gathering, sometimes being stored for a very long period of time, and sometimes moving very quickly from one place to another. And that's what we're going to talk about, reservoirs and sinks. So those are the places that these different molecules and chemicals are stored. So it's a place in the environment where a compound or material is collected. The ocean, for example, would be an example of a reservoir or a sink. The ocean stores lots of different things, which we'll talk about and see here in some minutes. One of those is, of course, water. That's the obvious one. So the best way to learn about cycles and the movement of materials is to take a look at an example of a cycle. And so we're going to take a look at the water cycle. Should be one that you guys are pretty familiar with. So I want to go ahead, and you should have this in front of you on your notes. And what I want you to do is I want to find out what you know about this this cycle before we go through it. So there's numbered 1 through 7 there, and what I'd like you to do is I'd like you to pause this video, and I'd like you to take a shot at labeling what you believe the numbers are represented here on our water cycle picture. So go ahead and pause the video and take a moment to do that. Okay, so now that you've taken that moment to go ahead and pause the video and get that stuff written down, I want to go ahead and take you through the water cycle and see what you knew and kind of learn a little bit about how this works. So for water to move throughout the planet here, we've got a lot of things going on, a lot of spheres interacting with each other. The first thing we've got going on here is light is coming to the surface, and heat energy is coming to the surface of the planet through our atmosphere. And that, of course, comes from the sun, radiant energy from the sun. So that's number one, is if you were thinking something along the lines of sunlight or sunshine, you were spot on. That energy drives the movement. I mean, you can't have something like movement without energy provided, and that's where the sun comes in. So water's moved through winds, through movement up and down, and all of that is caused by the energy from the sun. Makes a lot of sense if you think about areas where hurricanes and typhoons happen, for example. It takes a lot of energy for those type of storms to develop and to happen. And so they happen in some of the warmest water in our oceans, and they happen in some of the warmest places around the equator on our planet, which makes a lot of sense, because that's where the most radiant energy is. The cycle, things generally are moving in this direction, but I want to kind of just work my way down the numbers here. So number 2 here, there's two things happening here. We see clouds. Clouds are a great example of something called condensation. So what's happening here is that water vapor in the atmosphere is changing due to that water vapor rising high enough in the atmosphere that it's cooled. And that cooling brings the temperature of the water down to the point where it changes from a gas into a liquid. So when you see a cloud up in the sky there, a lot of people think of that as water vapor, and of course there's a lot of water vapor in those areas usually where clouds form. But it's actually liquid water that's up there in the atmosphere, collecting on dust particles and things like that to form clouds. And that's called condensation. Of course, you can see that here on the surface as well. If you have a nice hot day and you have a nice cold drink, the cold drink is removing the heat from the air around your cold drink, and that usually causes condensation to form on the outside of your glass, because the warm air that holds water vapor around the outside of the glass is getting cooled to a point where that water condenses and turns back into a liquid, and usually is sliding down your cup. The next number down that I want to go through and talk about a little bit is number 3 here. And I hope that you guys guessed that this was evaporation happening. So evaporation, as you guys probably know, is when water changes from a liquid into water vapor or gas. And so here we have a lot of evaporation happening. The orientation of this picture is important because evaporation happens all over the planet, but if you think about how large the ocean is, a lot of water is evaporated and it goes up into the atmosphere over the oceans. So a lot of times we think of that cycle as water evaporates from the ocean, rises up, winds blow it onto land, and then so a lot of that water then is falling down. So a lot of our, even here in the middle of our country in the continental United States, a lot of the water that rains down on us came from evaporation that happened over the oceans. There's just so much water in the ocean, it's got to happen that way. The next number here, again, I hope that you got this one, that you knew what number 4 was, and that, of course, is precipitation. Precipitation can fall in many forms. It could be rain, like what's showing here in the picture. It could be snow, sleet, hail, all that kind of stuff. Anytime water in the form of frozen form or liquid form falls from the sky, we call that precipitation. And a lot of that, again, falls over the ocean because the ocean is so large, but plenty of it also goes on land and provides a source of water for much of our groundwater, streams, rivers, lakes, ponds, and those kind of things. Next thing down the list, of course, we have here the ocean, which is, again, like I mentioned before, is a sink or a reservoir for water. And actually, now that I said, all these locations, as we move through the water cycle, are reservoirs or sinks for water moving throughout the planet. The atmosphere is a sink. Water vapor and liquid water trapped in the atmosphere. Water on land, of course, it doesn't stay in that sink for very long. But water can spend a very, very long time in the ocean because there's just so much of it. So the ocean is a big sink or reservoir for water. All right, the next one here, it's probably hard to tell from the location here, but you might have figured this one out. I'm looking at the water here that's running on the surface. And this is called runoff, which again is very important. We rely heavily on this kind of water for drinking, for recreation, for use for all kinds of things. Water in rivers, lakes, streams, ponds, underground water, and even glacial water would be considered part of this. So runoff is really important. And then the last one here, man, it would be outstanding if you guys got this one, but I doubt many of you did. And this is an important one, and it's often left out of simple water cycles that you would have learned about in elementary school and middle school. Water, of course, is essential for life, and the biosphere plays an important role in the water cycle that's often left out. And so obviously we drink water, we consume water, and then we also excrete it as a waste product in our urine. And that, of course, works its way through there. But in plants, there's a special operation that happens called transpiration. And what transpiration is that's when mostly plants, and remember guys, there are lots and lots and lots of plants all throughout the planet. So it's a big source of water getting back out into the environment. Plants release water as a byproduct when they photosynthesize and produce energy. So that water is released out of pores on their leaves, and it sits on the leaf. And then, of course, as it warms up throughout the day, evaporation is going to evaporate the water on those leaves, and that water will move up into the atmosphere. So you might have heard of the term evapotranspiration, which combines the two things. So on the surface of the leaf, first transpiration happens and water exits the leaf through a biological process, and then evaporation happens, which is a physical, chemical process, to move that water from inside the biosphere out back into the atmosphere, so moving it from one sink to another. And so, of course, that's a critical part of the water cycle that's often forgotten about. So now you kind of see how these materials can move around from place to place. And it's also important to know that although water generally moves in that direction that you see the arrows going here, a cycle is not, again, we simplify it, it's not a set thing. Water, of course, could fall into the ocean as precipitation and then evaporate back out again and float around as water vapor and eventually condense and then precipitate right back again on the ocean. So it doesn't have to go through all of these steps. Each water molecule doesn't go through all these steps. Of course, there's variation there, but this gives you a general impression of how water moves throughout the planet. Okay, now that we've taken the time to learn a little bit about the Earth as a system and how materials are cycled throughout that system, let's go ahead and take this time to review. and answer some questions. You should have these in your notes there. What I'd like you to do is go through these and write in what you feel like is the best match. You're basically matching the descriptions here in the middle with the words and writing them over here. So I'd like you to go ahead and pause the video, work on those in your notes, review those words that we've been learning throughout this lesson, and then you can resume the video after that to finish up. Okay, so now that you've completed that on your own, let's go ahead and go through and just check your answers real quick. Again, if you have something different down than what I put, if you have a couple of words switched around, leave what you wrote on your notes and just add in the correct answer so that you have in your notes what is the correct match for the definition. Okay, so the part of the Earth where life exists, that is going to be, and hopefully you have it also, the biosphere. So we'll just pop that over there. The change of state from a liquid to a gas. So when water, for example, goes from a liquid to a gas, we call that evaporation. So I found that over here and drop it over. The process by which water is released from plants, that was talked about during the water cycle explanation, and that is called transpiration. So I'll drop that over here. Any form of water that falls to the Earth's surface from clouds is called precipitation. So you got that one. The solid outer layer of Earth that consists of the crust and the upper part of the mantle. Oh, this is a tricky one because it's not the geosphere that you're thinking of. The geosphere includes all of, not just the crust, but the mantle and the core. And so the crust and the upper part of the mantle is part of the geosphere that we call the lithosphere. The Earth itself inside is actually broken up into several different smaller components. Kind of similar to how I know you probably know that like the cryosphere and the stratosphere are part of the atmosphere, for example, even though we don't consider them one of the four major parts. So sometimes lithosphere and geosphere are used interchangeably. So here we'll drop lithosphere in for that one. Next one, the portion of Earth that is water, and hopefully you guys were able to make that good choice of the hydrosphere. The change of state from a gas into a liquid, the opposite of evaporation, is called condensation. And finally, a unified set of physical, chemical, biological, and social components, that's going to be the Earth system. So now you guys should have those. Now's a good time to go back through and correct things. I'm just going to check and make sure that I, your teacher, have the right answers, and I do. So that concludes this lesson. Feel free to go back and collect any notes that you needed, and otherwise don't forget to submit this assignment, your notes, so that they can be given credit for.